Hello students, we are going to continue our discussion on wave optics, and today we will start a fresh brand new chapter, that is your interference of light. So let us try to understand the phenomenon of interference, that is the wave phenomenon. And interference of light we will be discussing here, but interference is a wave phenomenon, so it will take place both in light and sound. That is, interference is valid for both light and sound. So we will discuss interference. In order to understand the interference of light, it is basically redistribution of light energy. And that redistribution of light energy takes place according to the principle of superposition. So first of all, we have to understand the principle of superposition. Principle of superposition of waves suggests that if two waves are there, suppose one wave source is here S1, another wave source is here S2, and this is the point P where these two waves are reaching, then the displacement provided by this wave is, suppose S1 is providing the displacement y1 to this point P and S2 is providing the displacement y2 this point P, then the net displacement of this point P is given by, according to superposition principle, y net is equals to y1 plus y2. See, this is basically your superposition principle, and in this case you should understand very carefully that it is not essential that it is valid for only two waves. If more than two waves are there, then we will be allowing y1 plus y2 plus y3 like that only, keeping sign in mind that whether it is taking it to upside or it is taking it to downside. So this is the y net displacement. This is called your superposition of waves. Now what does it mean? That we will understand in a better way. That you see that suppose here we have to understand in this way, that suppose a wave is here plus this wave is here. Suppose this is y1 and this is y2. Then this resultant will give you a wave y net here we are getting y net is equals to y1 plus y2. Now what is important to understand, that here the wavelength remains the same and the frequency remains the same. As I told you that I will be talking about coherent source. So these are the two displacements provided by the coherent source, and then the net displacement is given by this one. Here both waves are meeting in same phase, interfering in same phase, so the net displacement is more than the individual displacements, and this is called your constructive superposition. The result of constructive superposition will be your constructive interference. Similarly, if we take the wave in this way, here you will observe that the net displacement y net is basically your difference. Amplitude has reduced. So this is called your destructive superposition. So two waves we have considered, and that net displacement is given in this way. So this tells about the principle of superposition. Now I would like to tell you about the coherent sources. What is coherent source? Because for interference, first thing we have to understand the principle of superposition. According, see, two particles if we consider are moving then along the same line, then the result will be collision. Whereas in case of waves, the result is superposition. So superposition of waves is basically giving rise to, we people, the phenomenon of interference, that is redistribution of energy takes place, and this is especially your wave phenomenon. Now we will try to understand the coherent source, because for interference coherent source is also essential. Coherent source of light is that source of light which emits continuously light energy of same frequency, same wavelength, having zero phase difference or constant phase difference. Try to understand. So same frequency, same wavelength, third point is between two waves zero phase difference should be there or constant phase difference should be there. If these conditions are satisfied by the two sources of light, then we call them as coherent sources. Now a single, here you have to understand a point very carefully, that two independent source can never behave as coherent source. Two independent sources of light can never behave as coherent source. For example, I am taking two lasers, red laser. Even though these are emitting light of same frequency, same wavelength, but these are not coherent. And when they are not coherent, you cannot get the interference. So you should always keep this thing in mind, that for coherent source, we need single source which should be divided into two parts. So how it is possible? So how can we get the coherent source? For coherent source, we can do in this way, that suppose here is a plane mirror, here is the source of light, here is the point, a ray of light is going in this way and one ray is going in this way. Now here this can be treated as your coherent source for point P. For point P, S1, S2, because it is from the same source that we are getting the two sources, so it can behave as a coherent source of light. Also one more thing we can take, that is in this way, that here suppose two slits are there, here is a source of light, then here is the screen, so this slit S1, this slit S2. Now in slit S1 and S2, they will behave as the coherent source. According to Huygens principle, they will behave as a source, and then this S1 and S2 can be treated as your coherent sources of light. So for coherent sources of light, what is essential? It is essential that from a single source we should get two sources. Then they will behave as a coherent source. They will have the same frequency, same wavelength, and at the same time the phase difference between them will remain constant, that will not vary with time. Here in case of two laser torch that we have used, here same frequency, same wavelength is there, but the phase is not constant and phase is continuously changing with time, so this will not behave as a coherent source. Interference of light is basically the redistribution of light energy. Interference of light is basically redistribution. It is basically redistribution of light energy according principle of superposition. According to principle of superposition from coherent source, interference of light is basically the redistribution of light energy according to principle of superposition from coherent source, due to which dark and bright bands. These dark and bright bands are called fringes. Observed on screen. Dark and bright bands are observed on the screen. Dark bands, why this dark band? Dark band is due to destructive interference, whereas bright band is due to constructive interference. So this is basically your interference, and in interference, if you will see that from two coherent sources you are taking the here, if this is the source S1 and its intensity is I1, here its intensity is I2, and here its intensity is IR, that is resultant, then IR is greater than I1 plus I2. Now you see, from coherent source you are taking from source 1 the intensity is I1, from source 2 the intensity is I2, and resultant intensity is IR, which is more than the sum of the individual intensity of the two sources from coherent source. And if this is the case of constructive interference, this is your at the same time, if we are taking here the intensity is I1, here the intensity is I2, here the resultant intensity is less than I1 plus I2, and this is your destructive interference. So constructive interference, what is important to understand? That for constructive interference the resultant intensity should be greater than the sum of the individual intensity, and for destructive interference the resultant intensity should be less than the sum of the individual intensity. If in case you are getting that I1 plus I2 is equals to IR, then no interference. In this case, we can consider the light is coming from the non-coherent source, incoherent source. So here the sources are incoherent. So what is important to understand, that in interference the resultant intensity of the interfering wave should be more in case of constructive interference and should be less in case of destructive interference. And if the resultant intensity is sum of the individual intensity of the two sources, then the sources are incoherent, and this is not we will call as the interference of light. One term is there that we all should understand, and that is your sustained interference. What does it mean by sustained interference? Sustained interference means this tells about the permanent nature. A interference is said to be sustained interference if it lasts for some time, so that we can make the study, and that is permanent in nature. If the interference takes place and we are not able to make a study of it, or we are not able to absorb it, it happens so quickly, then we will not call it as sustained interference. So for sustained interference, what are the conditions that we should know? Conditions for sustained interference is that first thing is there, coherent sources of light should be there. Second thing that should be understood, light should be monochromatic in nature. Monochromatic means what? Monochromatic means single wavelength or single color, either red, blue, green, any single color. And third condition is that the path difference between the waves should be small. If the two interfering waves are there, and amplitude is not essential that they should be nearly, if they are nearly equal. And fourth condition we can have amplitude if amplitude is nearly equal, then we will be having the better contrast is available in the interference phenomenon. That means dark will appear complete dark and bright will appear complete bright, and then a better understanding of interference phenomenon we can observe. Better understanding will take place. So these are the conditions for your sustained interference. Now what I would like to tell you, I have used the word path difference and I have used the word phase difference. This path difference and phase difference are related. Phase difference del phi, path difference and phase difference are related by this relation, that phase difference is equals to 2 pi by lambda into path difference, where lambda is the wavelength of light. Now this relation is very simple to derive, and you should remember this relation all the time very carefully. Now what is path difference? You see here a source of light is S1, here the source of wave is S2, and they are generating the wave. We are considering the point P. If at point P it has covered a distance x1 and it has covered a distance x2 and x2 is greater than x1, then x2 minus x1, this is your del x and this is your called path difference. So path difference and phase difference are related by this relation, that del phi is equals to 2 pi by lambda into del x, and path difference is this one, and this path difference gives rise to phase difference, and we will see that how the intensity depends upon this phase difference. So you should understand very carefully that what is phase difference, what is path difference. In terms of wave, if you want to see, I can tell you here. Here this is basically telling about the path difference. If this wave is there and this wave is there, here this much is the path difference between the two waves. In detail we will be discussing about it also while doing the calculation, but right now you should understand it very carefully that phase difference del phi is equals to 2 pi by lambda into del x path difference, or you can say in this way also that path difference del x is equals to lambda by 2 pi into del phi phase difference. This is also the same way of representing the relation between phase difference and path difference. Now we would like to understand the condition for interference. What is the condition under which interference will take place? So in order to find the condition for interference, I am taking two waves. Suppose y1 is equals to A1 sine omega t. This is one wave, and y2 is equals to A2 sine omega t plus phi. This is the another wave. Phi is the constant phase difference. Phi is the constant phase difference that will not change with time. If we consider, according to superposition principle, y net should be y1 plus y2, and if we take it can be written in this way. Here we can expand it in terms of sine A plus B. Sine omega t is common. Now what I am going to take, I consider this as, let A1 plus A2 cos phi is equals to A and take it as equation number 1. So if we substitute this value, then y net is equals to so what we are getting, A net sine omega t cos theta, A net cos omega t sine theta, sine theta. So this is giving you now you see it carefully. So what I am going to tell you, I am going to tell you that here y net is equals to A net sine omega t plus theta. That means if this is the individual component are SHM, the resultant is also a SHM. So y net we have got A net sine omega t plus theta. Now the question arises here that what is the value of A net and what is the value of theta? What is the value of theta? In order to find the value of A net and theta, what I am doing, first I am squaring and adding 1 and 2. So 1 square, equation 1 square plus equation 2 square will give you A net square cos square theta, A net square sin square theta. That means we are getting A net square. RHS we are getting. LHS this square, this we can write so we are getting, now this A2 square is common, so we are getting A1 square a2 square sin square phi plus cos square phi is 1 plus 2a1 a2 cos phi. This is the value of a net square. This I am giving in cloud that you should remember all the time. And if we want to find the value of theta, then you see the theta. I am dividing sine by cos. So tan theta a2 sine phi by a1 plus a2 cos phi. This value is giving you here. You all should understand that whenever the two waves are given, basically we have to find, in order to find the resultant wave, when we want to find the resultant wave or the equation of the resultant wave, we have to understand that first we have to find, the problem is to find the a net. First you have to find a net. This a net we have to find by this relation, and this theta we will have to find by this relation. So always remember this thing, that this will be very helpful to you in finding, if the two equations are given, two waves are given, then the resultant wave equation we can find easily with this relation. So this is very important for you and you should remember it in a proper way. So this is giving you the net amplitude of the resultant wave, and this is giving you the theta, value of theta, which is the phase of the resultant wave. So we are able, which is the theta is the omega t plus theta. So this theta is the resultant wave phase that we have to remember. So after remembering this thing, many questions can be framed, that if y1 is given, y2 is given, how to find y net. This question is very important and it has been many times asked in the entrance examination, that y1 component is given, y2 component is given, and you have to find the y net. But before that, I would like to tell you, I was basically talking about the condition. So regarding condition, here phi plays the important role in determining the value of a net. It is a commonly known fact that intensity, whenever we are talking about light or sound, we don't see the amplitude, we don't see the frequency, we don't see the wavelength. It is the intensity that we feel. So intensity plays a very important role. So what I would like to tell you, you already have the idea that intensity is proportional to amplitude square. This is your amplitude. Intensity is proportional to amplitude square. So if we see here the resultant intensity I net, we will get I1, intensity of first, intensity of second source, plus 2 root I1 I2 cos phi. This is the net intensity. I varies as amplitude square. So what can we say? We can say that intensity will be maximum, I net maximum. And what is the maximum value? Root I1 plus root I2 whole square when cos phi is equals to plus 1. That is cos 2n pi, general value. So we are getting phi is equals to 2n pi. Now this is the important result that you have to understand for maximum intensity. And for what is maximum intensity? That is constructive interference. And what is the constructive interference? Constructive interference is basically telling about your brightness. That means you will observe brightness if this condition is satisfied. And as I told you that the phase difference and path difference, phi is the phase difference, phase difference and path difference are related with each other. So path difference this condition has to be remembered all the time, that for constructive interference, the phase difference between two interfering waves should be even multiple of pi, or the path difference between the two interfering waves should be integral multiple of lambda. Here n is equals to 0, 1, 2, 3, dot dot dot. So this tells about the condition for your constructive and destructive interference. So constructive interference condition is this, and similarly we can get the condition for the destructive interference also. In case of destructive interference, what will happen? In case of destructive interference, the intensity will be minimum. For destructive interference, this value, net intensity should be minimum, and when cos phi is -1, so cos phi is -1, that is, it is giving you root I1 minus root I2 whole square, and here you are getting the condition for destructive interference. And what is destructive interference? That is for darkness. So for darkness, what you are getting, phase difference should be odd multiple. Here we are taking n is equals to 1, 2, 3, dot dot dot. So what about the path difference? If we talk about the path difference, so for destructive interference, the phase difference should be odd multiple of pi, or the path difference should be odd multiple of half wavelength. Lambda by 2 is there, here lambda is there, here lambda by 2 is there, so be careful. So what I mean to say here, that this is the condition for your constructive and destructive interference. In the sustained interference condition, or condition for interference, as I told you, I have written the condition that it is your amplitude should be nearly equal. Why I told that amplitude should be nearly equal? Because in case of, if the amplitude will be nearly equal, then this will become maximum bright and this will become 0. So bright will be complete bright and dark will be complete dark. Therefore, I said in the discussion that amplitude should be nearly equal for better contrast. So I am writing it here. So amplitude of the wave should be nearly equal for better contrast in the interference pattern. The interference pattern will be better with maximum contrast if amplitude is nearly equal. Now this matter you have to keep in mind very carefully, and hope it will be helpful to you, and in the next session I will be discussing with you certain problems based on this concept. Thank you. Have a nice day.